Hey guys, so in section 5 of the course, which is the last section, we're going to be talking about arrays and loops. And in the first example, we're going to start off with simple arrays. So the first line of code here in my example is a variable declaration, and it looks just like every other variable declaration we've ever done before, except for one thing, which is these brackets here. So my variable array of integers is not of type int, it's actually what is read as an array of ints. So by putting the two brackets after the type int, you're saying that there's not only going to be one int inside of this variable, but there's going to be many ints. It doesn't say how many, it just says I'm going to be able to contain more than one int. So an array is like a variable that can contain multiple values. That's what an array is. The formal definition of an array is actually a homogeneously typed and contiguous block of memory, which means contiguous being every value in memory physically is one after the other. So they're all lined up right next to each other. And homogeneously typed simply means they're all the same type. So in this case, an int array, we have a list, an ordered list of all ints. So there's one particular property that you want to remember is that they're all the same type, and the other property that you want to remember is that they're ordered. So we're going to be able to say what's the first int in the list, what's the second int in the list, what's the third int in the list. So the reason that's important is because there's other data types like tables and dictionaries and things of that sort where when you look at the collection of data you say give me the value based on a key or some other type of information. But with an array you have to provide the position in the array once you want to get it back. So you'll say give me the third element of the array, give me the seventh element of the array, and so forth. So this is the first step in using the array data structure, is simply declaring it. Now, since we did not provide the size of the array, we simply declared the variable, we actually don't have any usable memory yet. We just have a variable that says, okay, I'm going to be able to reference an array of integers, but I'm not sure yet how many there's going to be. So the second line of code here on line 13 is actually what we call dynamic memory allocation, in which we're going to be physically creating three integer variables inside of our one variable. So I'm sorry, I said that wrong. We only have one variable, but after the memory allocation step, that one variable is going to have enough memory to store three integers. So as you can see here, it uses the new keyword just as we use when we instantiate an object, but instead of a constructor for a class after the keyword new, we have once again the name of the type, which is an array of integers, but this time a number inside of the bracket so that it knows how much memory to create. So that line is saying, take this variable that I declared to be able to point to a block of integers, an array of integers, and now create enough memory to store exactly three of them. So after these two lines of code, and again you can combine them, so instead of having just one line for the declaration and another line for the allocation, you can do a compound statement like that. And that's what you'll usually see. So just keep that in mind. I split it up into two lines for clarity, but usually you'll be able to combine them with a compound statement. So at this point I have my array and I have the memory allocated for it. So after those two lines of code are executed, I have my variable array of integers, which has the ability to store three integers. So the way that we actually put in values is by using the index operator, which is once again these brackets. And these read, the way this reads in English, array of integers, we say sub. So sub 0, sub 1, sub 2, sub 3, sub 4. So this says array of integers sub 0 equals 15. That means since 0 is always the first position in the array in C#, you can say that however you want. Some people call it the first element, some people call it the 0th element, but it is indeed the first element of the array. So this says go to the array of integers in the first position and assign that first position the value of 15, and that will work just fine. And we get to this next line of code, we go to the second position, or sub 1, and give it the value of 27. This line here goes to the third position, sub 2, and gives it the value of 39. Now, we only created enough memory for 3 integers. So I intentionally put these other 2 lines of code here so that you can see that these will compile just fine, and we can actually run the program. But when I get to line 18, it will attempt to put this into a place in memory that doesn't exist. So you'll see line 18 crash with an out of bounds or out of range exception. So index out of range exception was unhandled. So be careful of that. You'll see that error sometimes when you accidentally try to access a position in an array which is not there. So that's better. And I did the same exact thing down here. This next example is the same exact example as this other one here, except I declared an array of strings. And this is just to show you that you can have an array of anything. You can have an array of integers, you can have an array of strings, you can have an array of whatever you want. So once again, I declare my array, I allocate memory for my array, so I have 3 strings available, and then I go through my positions of the array one at a time using the index operator and saying array of strings sub 0 equals this string, sub 1 equals that string, and sub 2 equals that string. So again, the array gives you the ability to, with one variable, store multiple values. So slowly getting there. The next example is a little different in that instead of using a primitive type, I'm using a class called widget. So at this point, I will just assume that I know what widget is. Actually, let me hover over to it. I'm going to right click on it and I'm going to say go to definition. So what is a widget? A widget has an ID, which is an integer, and it has a description, which is a string. And it has get set methods for both, and it can print itself. Okay. So we have some widgets. So these 2 lines of code look exactly the same as previously. We declare the array. We create enough memory for 3 widgets. So here's the big difference. Whereas in the previous case where we had primitive values inside of the array, the moment we created the memory for the array, we were good to go. We said, okay, like for example up here on line 23, we said, okay, after this line, we now have 3 strings available in memory that we can immediately access and look at them and give them values, as we did right here. Boom, boom, boom. So line 23 immediately creates those 3 strings. However, if we're working with objects, which are not primitive values, what does this actually do here? So let's think about this. This is probably the most important line of code. Line 33, when it says new widget of size 3, that means give me a new array of widgets of size 3. So that will create the array with 3 positions in it with blank values. So when we ask ourselves what is the blank value of a class or of an object, the answer is null. So you have to remember that at this point right here after that, array of widgets sub 0, array of widgets sub 1, and array of widgets sub 2 are all going to be null. So once again, I'm going to repeat that. When you instantiate, when you create memory in an array for objects, that doesn't mean that you are actually creating any objects. It doesn't do the individual object instantiation for you. It just gives you an array of size whatever, in this case 3, that you can go into each one of them and instantiate objects if you want. So there's kind of an extra step to remember here. Whereas with the primitive values, you just said, oh, now I can go through the array in each position and assign them values. With objects, you can't really do anything until you actually give them a value. So what I want to get across is that if you don't have any objects, you need to instantiate them. So there's kind of this 3-step process. You declare the array, you create your memory for your array. So now you have 3 variables basically baked into this one array, but you don't have any objects yet. So don't get confused, and this is what I find some people get confused with, that I have highlighted right there. They think by saying new widget 3 that you're actually creating 3 widget objects. That's not the case. What's happening is it's simply creating an array of size 3, and you can go into any one of those 3 positions and create a widget if you like. But it doesn't do that for you. All it does is give you 3 positions that are all null. So keep that in mind when you're using an array of objects. So what I do, the very first thing I do is I say go into the first position of the array and instantiate an object. And at that point, I will actually have an object in the first position. Since the first position in the array is an object, I can refer to array of widgets sub-0 and treat that as a widget. The reason that I can treat this as a widget, how do I know that array of widgets sub-0 is of type widget? Because, like we said before, an array is homogeneously typed. So we know from the very get-go of the variable declaration that every single object inside of this array is a widget. Therefore, we can index the array and automatically we treat that like a widget. See, even if I hover over it, it's saying on my screen that this is a widget array. And that means I can call the methods that are defined in the class, which, as we saw, were setID and setDescription. So I can do that for all 3 positions in the array. So just to prove to you that this works and also to see it happening, let's debug through this. And let's see, where am I put a breakpoint there. Alright, why are you way over there, locals? Just get this looking good here. Okay. So my array of integers is created. I'm going to expand this down here. So as I can see, the array of integers has 3 positions in it. And I'm going to start putting in those values, 15, 27, and 39. So one at a time, we saw all those 3 values go into the position 0, position 1, and position 2 of the array of integers. So let's watch it a little closer with the string array here. So I've declared array of strings, but I have not yet executed line 23. Line 23 is going to create the memory for the array of strings. See, right now, array of strings is null. There's no memory created for it. But when I execute this line of code, it's going to create enough room for 3 strings in the array of strings. So if I hit F10, now we can say it created enough. We can see in the locals window that it created enough room for 3 strings. If I expand it, I can see it has null, null, null. And now I'm going to go through each position one at a time and give it the value of a string. 1, 2, and 3. So there's my 2 arrays. They have values in them. And now, the final and slightly more complicated one, the array of widgets. So my array of widgets, it's null. So remember I said line 33, pay close attention to what this is doing. It says new widget 3. So when I do that, it does say I have an array and there's 3 positions, but when I expand it, look what's inside. Null, null, null. So each one of these can be a widget, but it isn't yet. But if I go and I say array of widgets position 0, instantiate that as a new object, now all of a sudden that first position I have a widget, and if I expand that I can see the description and the ID are both 0. Now I'm going to invoke these two set methods to set the internal values of the description and the ID. So if I do that with all three, instantiate the second one, set, instantiate the third one, set, now I can expand all three of those positions in my array, and I can see the IDs and the descriptions, 75, 82, and 96. I think that is all. What did I do down here? Okay, so I just did a couple of print lines here at the end just to show you, and I don't really need to debug anymore. So array of integers dot length, this is showing that every array in C# has a built-in length property. So that's just part of every array. The moment that you put a bracket on a type, making it an array, you all of a sudden get a bunch of stuff out of the box that's associated with arrays. So you can always say whatever the array is dot length to figure out how long it is. So the value of this right here will be 3, the value of this will be 3, the value of this will be 3. It changes depending on how big the array is, but in this case all of our arrays were 3. And I also wanted to show you here that array of integers sub 0 is an integer, so I can print that out. It's just a number. Array of strings sub 0 is a string, obviously, so we can print that out fine. But look at this. Not okay. What is array of widgets sub 0? So array of widgets at position 0 is a widget. So this goes back to when we first learned about classes and objects. What is the value of a widget? It's an object. So that doesn't really make sense. You can't just print an object. You can't take an object variable and say what is its value. It's basically just an address of the object. So you'll get something that doesn't mean very much if you try to print that out. And every semester I see a few people trying to do this, and they don't understand why it's not printing anything out. They say, hey, I'm printing out this object variable and nothing happened. So I can go to the object and I can say, hey, get your ID, that's fine. I can say, give me your description, that's fine. But just saying print out the widget, that is not fine. So for example, if I had widget x equals new widget, and then I tried to print it out, that just doesn't make sense. So x is an object, and x has values inside of it, but x itself is just a reference. It's just an address to an object. So it doesn't make any sense to print it out itself. If you did that, what does it actually look like? You'll get something like the location of the object. Whoa. So anytime you get this error, where you see something like that gets printed out, example 4, it's basically the namespace and the name of the class. If you see that being printed out, it means you tried to print out an object that really doesn't have a value, it just has a location. So that's pretty much example 1, not too complicated, it's just the basics of how to create an array. The most important thing, I guess, is I want you to understand that there's 3 steps here. There's the step of declaring the array, there's the process of creating memory for how many positions available are going to be in the array, and then there's one step at a time going through each position in the array and giving that position a value. And in the case of an object, you're going to need to instantiate the object before you're able to do anything with it. And that's pretty much it. You might be saying to yourself, well, cool stuff can I do with an array? And for now, hold your horses for a few minutes. I'm going to do example 2 in the next video, loops, and then I come back and I will describe how loops and arrays work together, and you can really use them for a lot of cool things. They're pretty much the two aspects of the programming languages that allow you to implement data structures, which are the building blocks of most pieces of software. So by the end of all this, we should have a pretty good idea of why we can use this stuff and why it's so convenient. But right now, just focus on the syntax and the rules for how to create an array. And I will show you in a couple minutes here how to combine them with loops to do cooler stuff.